there, different mathematicians from around the globe. My name is Brent, and I will be teaching you all about radical equations. So radical equations are mathematical expressions that have or contain a radicand symbol in them. Now today, with these four examples, I will show you how to solve and eliminate these radicand symbol expressions. So first, we have solution number 1. This is a very simple and basic problem. So we have the square root of x is equals to 16. Now, what do we do first in the radical equation? Well, our main goal is to remove the radicand symbol and find the value of x. So how do we do that? Well, first, what we can do, since this is the very basic, we can square both sides. By squaring, it means multiplying the number or variable to itself. So we have square root of x squared and 16 squared. So what this will do is it will eliminate the radicand symbol, leaving us with x equal to, then squaring 16 as well, since we are squaring both sides. So 16 squared is equals to 256. See? It's very simple. Very, very basic and simple. That is our solution for number 1. Let's move on to number 2. For question number 2, we have square root of 3x plus 4 is equal to 4. Now here, what's different about this example is instead of only having a square root of x, the x now has a coefficient and it's 2 terms. It's a binomial. So, but even saying that, we can still use the same process in this specific example. So first, we have 3x plus 4, which equals to 4, right? We need to square both sides so we can eliminate the radicand. Till we're left with 3x plus 4. Then we square 4 too, and 4 squared is 16. Now, here is where I'm going to introduce to you another way or another rule or tip that you should remember. We still have a coefficient and another term. What we need to do here is combine like terms. So 4 and 16 are like terms because they're both whole numbers that doesn't have a variable or an exponent. So we can combine these two. Now I'm going to introduce to you a term. The term we use is called transpose. It's where we get a number or a value, move it over the equal sign, and change its sign. So this will become -4, right? Well, this isn't actually a mathematical term. What is actually happening is you're using the subtracting and additive property of inequality and equality. It just means that whenever you add something to one side, you need to add it to the other, or if you subtract one thing from one side, you have to subtract it to the other. So, but for the sake of this video, we're just going to use the word transpose. So we're going to transpose 4, and it's going to be 3x is equals to 16 when we're transposing a number over an equal sign. Note, take note. It needs to go over the equal sign for it to change in value. So it becomes -4. So we're left with 3x is equals to 16 minus 4. So if we continue the solution, 16 minus 4 is, we get 3x is equals to 12. And 16 minus 4 is 12. Now, we're left with a coefficient. All we need to do now is remove the coefficient. But how can we do that? Well, it's very simple. All we need to do to remove the coefficient is divide that 3x by 3, so we're left with x, and divide 12 by 3. So we are left with x is equals to 12 divided by 3 is 4. So this is our answer for question number 2. Very, very simple. Now, let's move on to question number 3. This is where things are gonna start getting a little bit more complex, as we can say. we have square root of x minus square root of x plus 6 plus square root of 2 equals to 0. Now, here I'm gonna introduce again another rule. We have three expressions here that all of them have radical symbols, right? Right. So what we need to do here now is we need to pick one radical expression to isolate from the rest before we start our solution. Now, I'm gonna give you a moment. Which one do you think the right one is to transpose? Well, let's get to it. The actual right one, well, it's up to you, but in this case, we prefer this one to transpose because it's a negative, and we don't want to deal with that yet. So we're gonna transpose it over the equal sign. So it's gonna become x plus square root of 2 is equals to square root of x plus 6. Now, what we can do here is now we can square both sides. So this will eliminate the radicand. We're gonna be left with x plus 6. But then we have this. It's a binomial. I know what you're thinking. You should just square it so to remove the radicands. No. What we actually need to do is something we do in squaring binomials. We need to square the first term, multiply both terms, and then multiply it to 2, and then square the last term. So, if we solve this, square the first term, so it should remove the radicand, it becomes x, plus we need to combine both terms. Here, both terms. So it's going to be square root of 2x. Square root of 2x. But we need to multiply by 2. So it's actually gonna be x plus square root 2 square root of 2x is equals, and we need to square this 2 plus 2. Now we're left with this. What we can do here is combine like terms again. These two combine like terms, so we're gonna be left with, and these two can be combined like terms. When we transpose x over here, we get a negative x, so this cancels out. The two x's cancel out each other. If we move this 2 over here, it's gonna be 6 minus 2, so we're gonna get 4, and this is we're gonna be left with 2 square root of 2x is equals to 4. If we divide both sides by 2, we get 2x plus 2x is equals to 2, right? Then we just remove the coefficient, so divided by 2, x is equals to 1. I know it's a bit trickier, but we just gotta isolate first. We have to isolate a radical expression, then we need to square it, but then the rest we need to square the first term, combine the two terms, and multiply the product by 2, and then square the last term, and then we proceed as normal. And now we're gonna go on to our final example. This will be the final example for the video. This is where it's gonna get a little bit complicated, but not impossible. So our final question is 5 cube root of x plus 2 is equals to 10. As you can see, we don't have it as a square root anymore because the index is 3. So now it's a cube root. Well, but if it's a cube root, then how do we square both sides? It's probably what you're thinking. But again, it's very simple. First, we can divide, since we have 5 here, we can divide these two by 5 since 10 is divisible by 5. So we're left with the cube root of x plus 2 is equals to 2. Now, what we can do is instead of squaring both sides, we can multiply each side by cube. So we multiply by 3 instead of 2. So this 3 cancels out this. So we're left with x plus 2 is equals to 2 cubed is 2 times 2 times 2, which is 8. If we combine like terms, we get x is equal to, when this transpose, it becomes a negative. So it becomes 8 minus 2. And 8 minus 2 is 6. So the final answer for this final example is x equals 6. Let's do a recap. We have 5 cube root of x plus 2 equals to 10. First, we divided both sides using the value of the coefficient, since 10 is divisible by 5. So we're left with the cube root of x plus 2 is equals to 2. Now, to eliminate the radicand symbol, just like before, instead of squaring both sides, we're gonna cube both sides to eliminate the index and the radicand. So 3 cancels out 3 and the radicand, and then we need to cube this. With cubing is multiplying the number itself 3 times. So it becomes 2 times 2, which is 4, times 2, which is 8. That's how we got x plus 2 equals to 8. Then we transpose 2, that means it goes over the equal and it changes in sign, so it becomes 8 minus 2. And then we get 8 minus 2 is 6, so x is equal to 6. That is all for today. I'm hoping you learned something from this explanation about radical equations. It's not that difficult. In math, there's a saying, just like how it is in math, in life, there is always a solution for every problem. Please like, maybe comment, leave a subscribe, check the other videos. I don't know. Up to you.